Hey guys, so this is a presentation to help you with the 1.06 lab. I highly suggest watching this till the end because not only will I help you as far as procedure goes, I also, from the last time I taught this, the discussion assignment, there were many people who left large portions of it not on there, so this will explain what you need to include. Alright, so I'm going to share my screen here. And first, let's talk about some equipment you may need. So I'm going to return to the class homepage here. So if you're on track with things, this lab is coming up on Friday. All right. But if you get to it a little bit late, you get to it over the weekend, and that's fallen off of the regular class plan, just come over here to class content, click on that first folder that says weather, then scroll down to 1.06 laboratory relative humidity. All right. So you've probably already been here, hence you found this recording, but there's the recording link. First thing you're going to want to grab is your student guide, because that has your procedure in there. Okay, so student guide. You can also grab this LRD, relative humidity, because that's the questions that you're going to end up answering in the dispute. It helps kind of organize the information so that you can answer the questions. Let me just open that up so you can see what that looks like in a second. Maybe? Okay. This also has a table that you're going to have to use, and I'll show you how to use this in a second. So it gives you a place to organize your data. These questions, though, specifically aren't the ones that you end up answering in the discussion assignment. So, but this table is definitely something you're going to need in order to answer some of the discussion questions. All right, so there's the information you need from the website. Some physical materials that you're going to need is 2 thermometers out of your kit. All right, these thermometers are a little bit different than what the lab describes, because the lab is assuming that you don't have this plastic casing around your thermometer, so you could actually put something on this bulb. Do not try to pop this out of here. You're probably just going to break it doing that. So I'm going to show you a different way to set things up a little bit. A dropper might come in handy, or just work by itself. Okay? And then those are things that come from your kit. You'll need water, which you should be able to get from your house somewhere. And then ideally, you're going to have some sort of small fan or something like that. If you don't have a fan, then maybe try to find like a piece of thick cardboard, but something that you're going to be able to, move back and forth and fan off the wet thermometer. Okay, so the lab itself suggests using a cotton ball. Because of the thermometers that we have, a cotton ball, I'm not entirely sure is going to be as effective. So I would take some paper towels, and for the one that we need to wet down, we're just going to completely wrap the bottom of the thermometer, and then just use a piece of tape or something like that or a string, just to hold this closed. And we'll get the paper towel wet instead. Okay, so you'll need one thermometer with paper towels, and the other one you can just leave alone. Okay, so let's look at this procedure. There are some good definitions here. If you need to use these in your lab report, do not copy them word for word. Put it in your own words. So procedure: secure a small piece of cotton cloth to the bulb of one thermometer using a rubber band. So again, you can try throwing a cotton ball on here, but I think it'll work more effectively if you use the full paper towel wrapped around the bottom, just because we have all of this plastic separating our thermometer from the cotton ball. If you have something with a larger surface area, it'll probably work a little bit better. So I'm putting another piece of tape on so that stays. Then make sure that it's good and covering the very bottom of the thermometer and not covering your scale so that you can actually read the temperature. All right, then wet the cotton cloth on the thermometer so it's saturated. The thermometer is the wet bulb thermometer. So to saturate this, you want to get it so wet that the cloth is actually dripping. Okay, so you can use your dropper. You can use a dropper to do that, or if you're working near a sink, just keep running the water over it and down the thermometer until it is just dripping wet. Okay, so you don't need to run it super fast. You know, get both sides nice and wet. Make sure you don't see any more dry spots. And a good thing is, if you squeeze it and some water comes out, that's good. That means it's nice and saturated. Okay, you also want to use, at most, room temperature water or cool water. Don't use your hot water. All right, so in that LRD, you want to record the temperature of both the wet bulb thermometer and the dry bulb thermometer. So I don't have an LRD printed off right now. I'm just going to record this on a whiteboard that I have here. Start, wet, dry. So my wet bulb thermometer is saying, see, between 26 and 28. So I'm going to call that 27 degrees Celsius, and I'm writing this in the wrong spot. And my dry bulb thermometer is saying right at about 24. Okay. So that's setting that up. And then it says make a hypothesis about temperature that each thermometer will register after you fan them. Will they continue to have the same reading or one of them be lower? If so, which one? Write your hypothesis in the space provided in your lab discussion. So just to help, because there's a different hypothesis you're going to have to record in your discussion. A good rule of thumb for any hypothesis is you want to write it as an if-then statement. And I'm actually going to have you do a slightly different hypothesis. Let's look at the discussion. Head next. So if you read through here, this is going to give you more descriptions of relative humidity in more depth than just that basic definition. I highly suggest reading here. And what I really want to get to is here, the discussion assignment. So it says, review the data you collected in the lab, define relative humidity, and write a hypothesis that explains the relationship between humidity and dew point. Okay, so before you're going to be able to write this hypothesis, you're going to need to understand what humidity and dew point are. All right, if we have time in class, we will discuss that. Otherwise, that is in that laboratory section here. It talks about both of those. But your hypothesis should be something like, if the humidity increases, then something related to dew point. All right, there's going to need to be, you know, more info here. Let me show you what I'm actually writing. So your hypothesis for that part should be something like, if humidity increases, then predict what's going on with dew point. All right, and that's going to involve some sort of description of what you expect to be going on with your thermometers here, right? Because these thermometers